So let's do an example now with gravitational mechanics. So this question here says, what would an 85 kilogram person weigh if they were 2,400 kilometers above the surface of the Earth? So a few important things to note here is that kilograms is a measure of mass. And when it's asking for a weight, it's asking for newtons or force. So we're going to want an answer in newtons. And another thing here, when we're dealing with problems like this, we don't want to be working in kilometers. The SI units are meters, so we want to convert this to meters. And the conversion for kilometers to meters is times 10 to the 3. And I want to go one step further with this and bring the decimal 1, 2, 3 spots backwards. So it's going to be 2.4 times 10 to the 6. So 3 spots backwards. We go 1, 2, 3 spots backwards. That's adding another 3 to this exponent. So now we have exponent 6 meters. Remember, this is equivalent to this, which is equivalent to this. They're all the same value, but we want units of meters, and we like this scientific notation where it's just one digit followed by one decimal. All right, so now let's look at some values that we are supposed to either memorize or will be given in the question. That is the mass of Earth. We need to know that the mass of Earth is 5.98 times 10 to the 24 kilograms. The radius of Earth is equal to 6.38 times 10 to the 6 meters. And G, which is our gravitational constant, is 6.67 times 10 to the negative 11. And the units on this are a little bit weird, but meters cubed per kilogram second squared. And what I want to do here, I have a little diagram here depicting what we're looking at. So we have the Earth, and we have a person, 85 kilograms, floating, or not necessarily floating, but they are 2.4 times 10 to the 6 meters from the surface of the Earth. And the radius of the Earth is 6.38 times 10 to the 6 meters. So keeping this diagram in mind, it's good to have a little visual of what the question's asking. Now let's start by actually solving the problem here. So our FG, this is going to be the force. This is the force we're looking for, how much the person weighs. It's the force of gravity acting on them. And for this, we have a formula. That is G times N1 times M2 all over R squared. So what values can we plug in here? Well, we know the value of G. Remember, that's given to us over here. And I'm gonna color code these a little bit. So let's make this orange. How about? So our G, and we're gonna write in orange, 6.67 times 10 to the negative 11 meters cubed per kilogram second squared. And our next, we have our M1 and our M2. So what are these masses? Well, this is going to be, we have two masses here. One's going to be the mass of Earth, and the other is going to be the mass of our person. So let's plug these in as well. And for the mass of Earth, I want to make this a nice lighter kind of a lighter blue. It says, how about this blue here? Be the mass of the Earth. I'm just trying to keep this organized so we can all follow along. So this is going to be multiplied by the mass of the Earth. Recall 5.98 times 10 to the 24 kilograms. And our last value, which is the mass, going to be the mass of the person here, 85 kilograms. So 85 kilograms all over radius squared. So what is our radius? Well, we have two distances. We have 6.38 times 10 to the 6 and a 2.4 times 10 to the 6. So our radius that we are actually concerned about is going to be this distance here from the center of the Earth to our object. This is the radius that we care about. So we need to add these two values. So let's write that like this. 6.38 times 10 to the 6 meters plus 2.4 times 10 to the 6 meters. And remember, this is our r squared. And I might as well put brackets around this. So I hope you can all follow along so far. This formula here we've brought down and just plugged in all of our known values. And now all we have to do is type these values into our calculator. So I'm going to write out some intermediate steps as we go, but first I just want to multiply these two together, and I'm going to add these two together. So 6.67 times 10 to the negative 11. And if this is too simple for you, you are more than welcome to speed up the video. But I'd rather show you the extra steps than not enough. Kilogram squared. And then our radius, when we add the two together, we get 8.78 times 10 to the 6 meters, and that will be squared. So now let's continue once again. And I encourage, as you follow along with this video, to try plugging these numbers into your calculator also and see if you can get the same answers, because practice is always beneficial. So multiplying these two terms gives us this value here. And then this denominator, when we square it, we're going to get 7.709 times 10 to the 13 meters. Sorry, the units on the top here is going to be meters cubed per kilogram seconds. And there's going to be an extra kilogram squared in there. And then I also forgot this squared on the meters here. So now let's take this down one step further. And we're going to get an answer 439.802. And the units, I'm going to write these out. I'm going to write down all the units that we have here over kilogram second squared, kilogram second squared, meters squared. So you can see this here, that's that meters squared, and all of this is this. Hope you can see where all these units are coming from. I'm just rewriting all these units just so that we will be able to cancel out some terms now. So what cancels out here? We have meters, these meters squared cancels out with, So we have meters squared here and a meters cubed here. So that's going to leave us, I'm going to rewrite the units we have. We have a meters on the top. And I did make another mistake. This kilogram, oh, nope, that's all good. So these kilograms, let's look at the kilograms now. We have kilograms squared over kilograms. So that's going to cancel out to just leave a kilograms on the top. And then we have seconds squared on the bottom. You can see the seconds squared. That's on the bottom. That's the only seconds squareds that we have. And I want you to see that our kilogram, this is the units kilogram meters per second squared. So that is the units for newtons. So when we rewrite this out, I'm going to round this to just 3 significant digits. So 440 newtons. So Fg is 440 newtons. So we're just about done here. I want to write out a closing statement. So therefore, a 85 kilogram person (2,400 kilometers) above the surface of the earth, would weigh how much? It would weigh how much? Well, we just found that value here. Would weigh 440 newtons. And that is a solution to this problem. I hope you're able to follow along with all the steps I've taken. I tried to color coordinate them so you can see where all these numbers are coming from and where in the formula they're all going. And also these units, this will be an important part with a lot of your problems, keeping track of these units. So again, I hope this all made sense, and that is the end of the solution to this problem.